All right, welcome to today's notes. Today we're going to be looking at projectiles. Projectiles are things that have been thrown, tossed, shot, anything like that. Once it leaves your hand, it's only under the influence of gravity. And so things like rockets wouldn't be a projectile, although we sometimes call them that. But for our purposes, a projectile are things that are going to be thrown, shot, tossed, anything like that. All right, we're only going to look at a special case of projectiles, horizontal projectiles, to do our math. Okay. Other projectiles we can look at for concept purposes, but for math purposes, we'll look at and concentrate on horizontal projectiles. That means the object is coming off of like a desk, or it is shot horizontally, which means there's no elevation to it, there's no rise to its shot, and that means that immediately the Vy on the downward part is 0. Vy is going to be 0 if it's rolling off a cliff, going off of a rooftop, falling off of a ledge, anything like that. And that means what we're going to have is a situation where the object falls due to gravity. So on the y-axis, we have some very specific data because the object is going to be influenced by gravity itself. So it's going to fall at an acceleration that is equal to g, which is the negative 9.8 meters per second squared. That makes this pretty simple because no matter, as long as it starts off horizontally going left to right, then the object will fall at the same rate. No matter how fast it's going, it will fall at the same rate. So there is a video out there that you can look at. Mythbusters took a look at this and proved that a bullet fired from a gun horizontally and a bullet dropped from a gun at the same height will hit the ground at the same time. So that's one of the things we'll look at in class, and you can look at it online if this is someone who's looking for this stuff online. Just put in Mythbusters bullet drop from gun. Okay, so on the y-axis it falls down at an acceleration due to gravity. On the x-axis would be this way. On the x-axis, we're going to say that there's no air resistance, and that means that the velocity of the object is going to remain the constant all the way. So as it's falling, it's also moving forward. It makes a nice smooth arc until it hits the ground. So that velocity on the x-axis will remain the same. That makes life easy for us also. And as we do experiments, we'll see that that's actually true. So if we had a velocity of 10 to begin with, it would be 10 on the x-axis all the way down. It's still going forward as it falls. Coming down, the velocity would actually start at 0, but then as it falls, the velocity will increase. So if these were all 1-second shots, or we start out a little bit smaller than that, then we would have an increase, and every second we'd have an increase of almost 10 meters per second as it fell down. And that same thing would be happening over here. We'd be looking at the same increase going downward. So that's the background, that's the concept that we'll be looking at. All right, here's some of the concepts. Newton's laws tell us that if you drop a ball and throw a ball horizontally at the same time, both will hit the floor at the same time. Why? Gravity. Gravity accelerates all objects. At 9.8 meters per second squared. What if an object is going really fast? Doesn't matter. It's going really fast horizontally, still gets accelerated downward at 9.8. Will they land at the same time if you shoot and drop? Yes. So the only time that would happen is if you're going really, really fast, does gravity not affect you? No. So gravity never quits. So this is a system where this is most of our concepts. Most of our questions on concept basis were based on these concepts right here, these statements. All right, so how does a projectile look? As the object rolls off the table, okay, it begins to fall. So it creates a little curved path here because it's still going forward as it falls. Now, these three objects coming from the same table will all hit the ground at the same time. So a snapshot taken would have them be at the same location horizontally. I mean vertically. Vertically, they'd be at the same location. Now, you could say from this concept, since V3, the object with V3 over here, is traveling farther away from the table, you could say with confidence that V3 has to be greater than V2, which has to be greater than V1. Wish we'd looked at this and put this on our test. This would be a wonderful test question, but we did not. So this is just a concept that should be easy to see. All right, and now on the right, here's a picture of things that have some angular projectiles, which means they have some lift to them. All right, so if you want to throw a ball farther, you have to give it a little bit of lift. And that's something that we learn just by going out and throwing a baseball or a football or tossing a basketball to somebody, kicking a soccer ball to somebody. To get it somewhere quicker, we give it a little bit of lift so that it will reach the object. And that's why people think that a bullet will not hit the ground at the same time as one drop, because they always know, if they've ever shotgunned, they know that you give the shotgun or the rifle a little lift, because you have to learn how to shoot at where the target is, and people have to sight in their weapons for the different distances they will shoot. Here in Texas, it's about to be deer season, and people spend a lot of time going and sighting in their rifles because there's a lift involved with how far away you shoot an object. All right, projectile motion to describe something like a bullet being fired, a basketball shot, a soccer kicked, an arrow's flight, etc. The arcs that are seen above are called parabolas. Okay, so these arcs, the path that a projectile will be following is called a trajectory. And the shape of that trajectory is a parabola. So the path is a trajectory and the shape is the parabola. Parabola is a mathematical expression, and it just means a smooth curve. If you cut this in half, it will be just as equal on the left side as it is on the right side. It can be thin from left to right, or it can be thick from left to right. It can be tall, it can be short, all sorts of things. All right, so we're going to separate this stuff into our y-axis going up and down, and our x-axis going left to right. We're going to work them independently. We're going to determine the time from the y-axis, and on the x-axis we're going to use the formula v equals d over t, and we'll solve for the velocity of the object as it leaves the top, or we'll figure out how far away it lands by rearranging the formula. So we can figure out the distance down here from left to right, but we only figure out one of those. We have to be given either the velocity or how far away it lands. And we're going to use a t-chart to separate it. A t-chart simply is a situation that it looks like a T when you make it up, and you have one thing on the left and one thing on the right. And so we're going to use a t-chart separating our information on our x-axis from that on our y-axis. On each axis, we're going to always look for the same things: our velocity along the x, our distance traveled along the x, and the time it takes. On the y-axis, we're going to look for our Vy, which will always be 0 for a horizontal projectile. We're going to look for our delta y, our change in our height over here, which will be equal to the negative of our height because we're going to drop. And then our acceleration will equal g, which is negative 9.8. So two of these items are always known: 0 for Vy and negative 9.8 for acceleration. And then over here, we're actually going to solve for the time over here, and then we're going to use that time and plug it in on the x side. So let's look at some problems. We have a ball shot horizontally with a speed of 10 meters per second from a cliff that is 23 meters high. How far away will it land? How long will it be in the air? Okay, so a little picture. I like to draw little pictures. If you draw the picture and you label it, that lets everyone know that you know exactly what's going on. So here's an object shot horizontally. Its beginning speed is 10 meters per second, and the cliff is 23 meters high. Now we're going to put this information over here in a t-chart, so help me by drawing a little t-chart in here. All right, the Vx is what they give us, that's the 10. We don't care about the time right now, and the d is going to be unknown, so we're going to put a question mark. That means we're going to solve for it. The height we're going to fall, so our delta y is equal to the height, and that's going to be a negative 23. Our vy is 0. Our acceleration is equal to gravity, and it's going to be negative 9.8. And we're going to look for the time. So once we've done our little diagram and our t-chart, we're going to work the y-side equation first. And we can use our kinematic equation, delta y equals vit plus 1/2 at squared. Because the vy is 0, we're going to get rid of the vi times t, because that's going to be 0. And we're going to end up with delta y equals 1/2 times a times t squared. We're going to rearrange that formula for you. And we're going to tell you that to solve for t, it's going to be the square root of 2 times the delta y divided by g. And this is a formula that we worked with when we did free fall, so it should be fairly easy for us to remember how to do it. Plug your numbers in. 2 times negative 23 divided by negative 9.8. And then you'll get your answer. Which I have somewhere. And that is 2.17 seconds that it's in the air. So it's in the air for 2.17 seconds. And as it's in the air, it's continuing to fall forward at 10 meters per second. So to figure out how far away it will land, we're going to use d equals v times t. And that's going to be equal to our velocity of 10 times the time it's in the air, 2.17. And that's going to give us that it will land 21.7 meters away from our cliff edge. So it will actually land over here 21.7 meters away. And we'll do some activities that show this, and amazingly enough, it comes out fairly accurate. So it's a real good approximation of where it's going to land. We have a 1,200 kilogram truck going to run horizontally off of a 10-meter building. So this is our delta y. How fast is the truck traveling? So we're going to be looking for Vx if it leaves a building that is 29 meters tall. And that is going to be our d sub x. So just a quick little picture. My objects are always circles. Just easy for me. So it's going to go off at some unknown speed. It is a 10-meter tall building. And it will land, and to help students see this, we like to put the little dots for our fall. It's going to land 29 meters away. So my x side, Vx, dx, and t. My Vx is unknown. I'm going to put a question mark. My dx is 29. On the y side, I'm going to find my Vy, which is always 0. My delta y, which is the negative of my height, so negative 10. My g is negative 9.8. And I'll solve for t. So t equals the square root 2 times negative 10 divided by negative 9.8. And that will be 1.43 seconds. So it's in the air for 1.43 seconds. During that time, while it's in the air, it covers 29 meters. So I'm going to be solving for the velocity that it left with by doing d over t. So 29 is my distance, and my time was 1.43. So put that in your calculator. You get 20.28 meters per second. All right, so those are the only two scenarios we're going to be looking at. Solving for the time in the air, and then solving for either velocity or distance along the x-axis. So that makes the concepts easy to concentrate on, because the math is going to be easy, because it's going to become repetition as we work these. All right, so we have an object shot horizontally off a cliff that is 30 meters high. It's going to be my delta y on the negative. And it lands 49.4 meters away. That's going to be my delta x, or my dx. So it's going to be the exact same scenario that we just saw with different numbers. This time we're really high, and we're going to land a little bit further out. So our x side of our t-chart, b sub x, d sub x, and t. On the y side, we always start with the v sub y, the delta y, the g, and the t is something we'll be looking for. Okay, so t equals the square root of 2 times negative 30, or negative 9.8. So put that in a calculator. You get 2.47 seconds. Right, while it's in the air, it's going to cover this 49.4 meters. So our Vx is going to equal d over t. So the 49.4 from our x side, right over here, divided by our time in the air, 2.47 seconds. And that comes out to 20 meters per second. That's our initial velocity as we leave the top of the cliff. So whenever they're going to do a movie or TV or a stunt and one of those things, they're going to go around, they're going to figure this stuff out. They're going to figure out how much speed do we want, where do we want to land. You know, if it's important that we land at a certain spot, they're actually going to do this math, and they're going to do it real quickly, and then they'll practice it before they actually go and shoot it. So again, Mythbusters does stuff like this. I like to send people to Mythbusters because when you watch the guys, they always have a little bit of time where Adam is going over and doing some math. And they always speed it up because no one wants to watch math on a math show and on a show, so they just throw it out there really quick. But you'll see him sketch a picture and put his math in there and do his calculations. And this is what he does. All right, a motorcyclist wants to jump from one building to another movie set. The motorcycle is traveling at 10 meters per second when it leaves, so that'll be my Vx. And it's going to fall 20 meters from one building to the other. So that's going to be my delta y. Will it make it across a 13-meter gap? Now, this 13 meters is only going to be for comparison. It's not going to be part of our math. So what we want to do, we've got a building. We're going to go from one to the other. Our speed is 10. And we're going to fall 20 meters to another building. So just work the same way. Vx is 10. Dx is unknown because we don't know what we're going to do yet. On the y side, still the same things. Vy equals 0. Delta y equals negative 20. G equals negative 9.8. Then we'll have t at the bottom. So t equals the square root of 2 times negative 20 over negative 9.8. So the time in the air is going to be a little bit over 2 seconds. And we're going to take that, we're now going to find the velocity, we're going to find the distance covered along the x-axis. So while it's in the air and falling in 2 seconds, so it starts out at 10 meters per second, 2.02 seconds, and that will give us a distance of 20.2 meters. And is that big enough to cover the gap? 13-meter gap, so yes, he makes it. And that's good. We don't want the stunt guy to die. So we want him to be able to make it across from one place to the other. And so this is what they do. And so a lot of the math that we're going to show, we're going to show you some of the things that they might do in a TV. Now, since we're on here, I'm just going to show you there's a little bit of difference. This is from the chemistry class. All right, if you shoot something up at an angle and it goes off at 10 meters per second, we have to separate that into the Vx and the Vy. So if you're interested in things like that, go to Khan Academy, or come in, if you're at the school, come into the school, and I'll be happy to show you how to separate these things by using sines and cosines of an angle to determine the velocity on the y-axis and the x-axis. And it changes up how you do, it doesn't change up your x chart, your t chart, doesn't change up writing that out, but it changes up how you start the process and how you get your math done. But it's the same math formulas, it's just can be more fun, but it taxes some of our regular students on going back and forth between the two. So good luck out there, guys.